K2CrO4. Just give me a table of KSP values, please. Here we go. Yeah, it's soluble in water. So typically, when you're dealing with solubilities, if you have potassium, if you have one of these three, and you can remember this, if you're going into AP, you're going to have to memorize these. And people remember it as SNAP or SNAC, depending on how you want to remember it. But this stands for sodium. This is nitrate. This is ammonium. And this is potassium. So these are always soluble. Yep. So if they have another partner here and they're listed as part of that thing, they're going to be soluble. Some people like to remember this as SNAP as potassium. I almost like to do it as SNAC because I don't want people to get this confused with phosphate or phosphorus. Okay. So that's why I like to try to use the K here. But, you know, the same could be said about sodium and sulfur. So, you know, it's however you need to memorize it. But at any rate, this is the potassium chromate is going to be soluble when you create that, because this is going to be potassium and phosphate, PO3. Don't know why the color change happened. Plus your calcium chromate. They are going to go in to form potassium chromate, which is aqueous because potassium always is. These are the only four in AP that you have to memorize, that you have to bother with. So it's not like you have to memorize that whole solubility table. This is it. And this isn't hard, I don't think. Once you get this kind of acronym in your head, you're okay. And then it's going to make calcium phosphate, 3PO4, 2. And so this is going to be your solid that's formed. And then were these net ionics or were these just, no, this, oh yeah, they wanted net ionic with this. So we're going to pull out, after we balance, I'm going to need a 3 here and a 3 here. And 2. I think I got it. Yep. Yeah. Okay. So now I'm going to pull out what I need for this guy to happen. So Ca3PO4, 2. I'm going to put my solid down here and I'm going to find the ions that created that. So I need this calcium ion. I need 3 of those. And remember, this is a net ionic equation. You have to have these listed as ions. So you have to put this on there. And then this is CrO4. I've got 3 of those. And no, I need my phosphate, don't I? I've screwed up on a couple things here. This is phosphate. There, that's better. Calcium phosphate. So I need 2 of my phosphates, PO4, 3 minus. There we go. That looks better.
Yeah, that's right.
And then these are both aqueous on this side, and that takes care of my net ionic. And I believe there's only one net ionic on the test tomorrow.
You just write the states. whether that aqueous or
Anytime you have a double replacement reaction, you have to have the states listed. Yeah.
both
At
sides?
least on the products. At least on the products.
Okay.
At a minimum on the products. But don't bother to look the reactants up. Just put them down as aqueous.
But you don't have to write them for those, right? Because those are just the reactants.
Yeah. Okay, so that was one. And then 15D she wasn't happy with because I had a typo on that one. So this one should have been sodium phosphate, PO4, copper 2 sulfate. And then I'm going to form sodium sulfate and copper 2 phosphate. Yep, I think that's okay. I need to put a 2 here, 3 here, and a 3 here. Not ionic then. This one's always going to be soluble because it has sodium in it. This one is going to be our solid. And so I need to pull that down. Cu3, PO4, 2. That's my solid. I find my things that contributed to this, which are 3 coppers, which are 2 plus, and 2 phosphates, which are 3 minus. That's my net ionic. Are these getting easy for you now, I hope? All the practice that I've made you endure? All the extra quizzes over and over and over again. All right. Any other questions here? All right. The one that typically almost every year comes up as an issue, this should be reaction, is this guy. This, I typically get a lot of questions on how to do this. Did you understand this at all? Good? Okay. Well, I'm going to go through it for some of you who aren't brave enough to ask, because I know traditionally this has always been kind of an issue. All right. If we look at this, we've got percent sign, and it's trying to sub in for number sign. Remember, if it's more active or it's a better player, then it's going to sub in. So obviously, percent sign is going to be better than number sign because it forced the number sign onto the bench. So percent sign is going to be higher up than number sign. And I'm leaving a little bit of room here just in case I have to sneak some other symbols in there. But we know this one's going to be higher than this one because it got replaced. Now over here, we've got dollar sign trying to sub in for number sign, but it didn't work. So that means that number sign is a worse player than, dollar sign is a worse player than number sign. Down here, the at symbol is replacing the percent. So that means that at is a better player than percent. And that's how we get this ranking to occur on here. And I personally think it's easier to do it kind of in a vertical row than it is to try to do it horizontally. So I do it vertically first, and then I put it into the blanks after that, just because my brain isn't able to do multiple step things sometimes. But I know that one comes up every year. All right, what else? Anything else that doesn't make sense you want to talk about?
You have to add liquids and gases to ionic equations as well?
Yep.
Okay.
To the net ionics, yeah. Yep, so the products, all states of matter for all products should be listed for double replacement reactions. If you have a double replacement reaction like this guy right here, your products need to have those states of matter associated with them. So here you're going to form sodium carbonate. You need to say that that's aqueous. How did I know so quickly that that's aqueous? Because it has sodium in it.
Sodium.
Yep. And this one's going to have potassium.
Sodium.
Okay. So these are my products. They're both aqueous. What am I going to write here? I'm not going to write double replacement. I'm going to write no reaction. If both of my products are aqueous, it's a no reaction.
On the test, do you want it balanced for no reaction?
No. If it's no reaction, I just write no reaction and you can move on. All right. Other?
Did you write that backwards?
These are the products. I just didn't write out the reactants. I just went right to the products because I knew that this was going to be I was just being lazy.
Okay.
And yeah, this isn't balanced. If you wanted to balance it, we'd have to put a 2 here and a 2 here. That would get it balanced. But it's a no reaction.
So it doesn't matter.
No.
Okay, so if there's no reaction, you don't have to balance.
Nope.
Okay.
Nothing's changing.
And what do you mean by the activity series at the beginning? The first question.
This is an activity series. So it lists what elements are more active or will do the replacing over others. So it's used in your single replacement reactions to determine if a reaction will occur or not. So Jordan Love is more active than Lippy. That's not true on many different scales. Okay, we talked about our quarterbacks earlier. My quarterback analogy. All right, what else? Anything else? Okay, so that is your review. If you have questions, let me know. Otherwise, I will give you time to finish